Solve for x. 3x to the 2/3 plus 5x to the 1/3 minus 2 equals 0. So this is close to a quadratic, but it's not quite a quadratic. However, if I make a quick substitution, like if I say u is equal to this item here, x to the 1/3, that would make this linear. And in addition, if I square both sides of this, I would have u squared equals x to the 1/3 squared. And rules of exponents would say this is x to the 2/3. So this x to the 2/3 gets replaced with u squared. And this x to the 1/3 gets replaced with u. So I have 3u squared plus 5u minus 2 equals 0. Now I have something that I can factor. Well, hopefully it'll factor. Let's see. Two things that multiply together to give me 3u squared would be 3u and u. And two things that would multiply to give me 2 would be 1 and 2. And I'll just assume those are the positions for the 1 and the 2 and check to see if that works. 1 times u is u. 2 times 3u is 6u. If this u was negative and this 6u was positive, they would add to 5u. So this needs to be a negative, this needs to be a positive, and then they also multiply to -2. So that's great. Now, I have two linear factors whose product is 0, so I can set each one of those linear factors equal to 0 separately and solve them individually. So 3u equals 1, or u equals 1/3, and u equals -2. Now, to finish solving the problem, I do have to go back to my original variable, x. And so I come back to the original transformation that I made, and I now say that x to the 1/3 power is equal to 1/3, and over here, x to the 1/3 equals -2. Now, to get x by itself, I need to cube both sides of these equations. And the reason I cube them is because rules of exponents would say 1/3 times 3 is 1, which would leave me just an x. So this is just x equals 1 over 27, and in this equation I get x equals -8.